All right, so here we have our, yes, our cantaloupe out in space. And I want you to imagine it has a couple of ropes tied to it. A rope pulling to the left with 3 newtons of force, and downward, and of course there is no upright left and down in space, but in this picture, downward. With your physics pointing finger, would you point for me in the direction of the 3rd rope that we're going to tie to this, and which way it would have to pull to provide equilibrium for this system? Yes. Excellent. So yes, it's going to pull this way with some force F. Does anybody have any ideas if the following is true? If ups equal downs and lefts equal rights, how big would F have to be to balance this system? Trey? 5 is correct. Why? Yes, it is. It's a 3, 4, 5 right triangle. So the component of F pulling to the right would have to be 3, and the component of F pulling up would have to be 4. And it'll make a 3, 4, 5 right triangle. Okay. So hopefully you understood that. So let's make it a little bit harder. Try this one. So again, we're in a 0 gravity environment, 0 G. And we're going to have a cantaloupe. And this time, there's an 8.2 Newton force pulling to the left, and a 6.5 Newton force pulling down and to the right at 37 degrees. Point with your physics pointing finger in the direction of the 3rd rope that has to be tied on, and which way will I have to pull to keep it balanced? Yeah. So.
What is that? 6.5?
Yep.
That's a 5?
That's a 5. All right, 6.5 Newton force. So your job is to find F, and we're also going to find theta. Now, I'll give you a big hint. It would be helpful if you could resolve these into their components.
Why is there space in between each other?
Good question. Trey said, how come there's like a space right here? Is that what you meant?
Yeah.
That's because there are 2 forces pulling to the right. Maybe for time's sake, how late do we go in this class? 1:45? Okay. I'll do this one as a demonstration. We're recording this, so keep it clean, my friends. I'll do this one as an example, and then I'll give you another one to work on, okay? So let's say that I label these components, these sides of the triangles, A, B, C, and D. If ups equals downs, what 2 vectors are equal to one another? B and D. So B must equal D. That is very good. And if left equals right, talk to me.
A equals 8, or 4C.
Haven't heard it yet. I got some good stuff, but not quite the right answer. 8.2 equals? Not A.
C.
Not C. A plus C. Yes. Nice job, new kid. Oh, look at him. Comes in from another class, and he got the right answer. You say that like it's an insult. It's not. Nerd? That is not an insult. Okay, well, if you're all nerds, first of all, and I am your queen, so let's not forget that. All right. So now, how about we find some of those vectors? Do you see why it's A plus C?
No.
Okay, maybe I should talk about that then. there are two forces pulling right-ish, 6.5 and F, correct?
Yes.
They both pull to the right to balance out against 8.2. Some of the 6.5 pulls to the right, some of F pulls to the right. Together, those have to equal 8.2. That's why I left the space, Trey. So it would be clear that those were two separate forces. Now, are they both exactly equal to 4.1?
No.
Probably not. Maybe. Maybe one of them is 5 and the other is 3.1. 2. Maybe one of them is 0.2 and the other is 8. How many possibilities are there?
Infinite.
Right. Actually, not infinite, because this is going to be determined. Can we find C and D in this triangle?
Yeah.
You betcha. C is equal to 6.5 times the cosine of 37 degrees. Remember that from projectiles? So if I solve that, I get 5.2. Oh, 5.2. If that's 5.2, what's A?
3.
Yes. So 8.2 equals 5.2 plus 3. We know what C, or what, oh, I did that backwards, but you get the idea. So this one is 3. Okay? Can we solve for D? Yeah, 6.5 sine 37 equals 3.9. And what else must equal 3.9? B. Good job. Now we can solve for F. How do we solve for F?
Pythagorean.
Mr. Pythag, that's right. F squared equals 3 squared plus 3.9 squared. F equals square root of 9 and 15.2. How about 4.9?
Yeah.
And then what trig function to find theta? Anyone, that is correct, anyone you want. Fallon, what's your favorite trig function? Tangent, that's my favorite too, my God. Fallon and I really are twins. Not that funny. Is that possible? Yeah, we do have a bit of an age difference. That's the only thing, though. 52 degrees. Okay. You ready to do a practice one?